Yeah, welcome back, guys. So in this video, we'll be implementing binary search. I hope it's recording. Yes, it is. So we'll be implementing binary search. Okay. So I think in the previous video we have seen the algorithm of binary search, how it is working, and in this video let's actually implement that using C programming. Right. All right. So binary search algorithm, you need some variables. First of all, first you have the array. You have to declare the array, okay? Because you are implementing this search and sorting algorithms using array only, because those are some easy data structures, so that you it will be more compact to implement those algorithms in using these data structures, maybe array or linked list. Okay, but binary search you can implement only using array. Okay, you can't implement that using linked list. Why? Because binary search is a linked list is a dynamic data structure. You don't have a fixed size. Okay, it's a dynamic data structure, and you can even add a lot of elements, right? I told you, right, it's a dynamic data structures, and you can the memory is allotted during the runtime of your program. It is not static, whereas array is static. Say if I say 100, it is static, right? This array can store 100 elements, right? That is the limitation. Okay, you can't manipulate that inside your program, whereas a linked list, it's completely dynamic. You can manipulate the size. So because of that reason, and the linked list binary search is not possible, and also it is not so efficient to sort the linked list. I told you in the previous video, please keep that in mind. If you want to implement binary search, then the array must be sorted. That is the first prerequisite you have here. The array must be sorted, then only you can implement binary search, otherwise it's not possible, right? So array must be sorted. Please have that in mind, right? So let's get the array first. I think I have my linear search code here, which we have written 2 videos before. So let me just copy paste some template code. Okay, uh, just getting the array as input, right? So these are just some template code which I have already explained. I'm not doing anything, I'm just getting the size of the array and the array elements, right? This will be same for all the searching and sorting algorithm, guys. This particular set of code will be same, getting the size of the array and getting the array elements. That's why I'm just copying that from the linear search, right? Uh, I hope I can do that, right? Super. Alright, so I've declared an array and I'm getting the array elements, right? I think I may be in need of a lot of variables here. I'll tell you why. Okay, and I need a variable called first, which will store the index of the first position or first element. Why? I told you in the previous video why do you need that, right? Whenever you want to implement binary search, you should have first element, last element and the middle element, right? So first, that variable will store the index position of the first element, guys. It will not store the exact element. Okay, it will not store the exact element, it will just store the index position of the first element. The let's say my array contains 10 20 10 120 34 56. Okay, these are my array elements. I have only 4 elements, right? Then first will not store 10, guys. It will not store 10. First will store the index position, which means the index position of 10 is 0, right? Because array index starts from 0. So first will have the value of 0. Okay, and you have last variable also. It will store the index position of the last element. Okay, and index position of 56 is 3, right? Because 0 1 2 3. So last will store the index position of the last element, which is 3. So it will store the index position, guys. It will not store the exact element. I am explaining you this because this may confuse you, right? So first, last, and I have one more variable which is similar to first and last. I have middle also, and middle is something important in case of binary search, right? Because we are making comparison only based on that middle variable. I explained the algorithm clearly in the previous video, right? Super. And I have n to which basically denotes the size of the array, and I have the element which I wish to search for, right? That is called as search. Okay, so search is the element which I wish to search, right? All right. So I think I have to get the element also, right? Okay, I have got the size, I have got the array. I have to get the element which I wish to search, right? So let me copy that code also. The element which I wish to search. All right. So this is the and I'll be entering the element which I wish to search, right? So that's it. After that, I think uh, yeah. First of all, let us have the first element to be 0, because by default the first element will have the index to be 0. Again, I'm repeating that is the index value, right? By default, array index starts from 0. So let me have first element to have 0. I mean the first variable to have 0, and last will be n minus 1, right? What is n minus 1? N minus 1 is nothing but the size minus 1. Okay, last is the index of the last element. An index of the last element will be n minus 1, guys. Okay, I could give you a short example. Let me take this example, right? And this is an array. Okay, this is an array. And what is the index value of, I mean, what is the size of this array? Size of this array is 4, which means this array will contain 4 elements, right? And that is n. N is the size of the array. Okay, you are getting the size of the array here. So n equals to 4 here, right? And index of first element is 0, 1, 2 and 3. What is 3? 3 is the index of the last element, which is 40, right? So index of the last element is 3. 3 is nothing but 4 minus 1, right? Which is size minus 1, right? So n minus 1. So you have to write the last element's index as n minus 1. That is size minus 1. Because since the index starts from 0, the last element will have the index n minus 1. That is size minus 1, right? And the middle will be the average of first and last, guys. That's it. Okay, and you are performing integer division only, so you will not get float values here. You will only get the integer values, right? First plus last divided by 2. All right, and I have to open a loop here, you know that, right? So the loop will continue, okay, until my first index, that is first index is less than last index, right? So till my first index becomes greater than the last index, the loop will continue to execute, right? Till my first index is greater than the last index. Understand that sentence, okay? You know about binary search algorithm. If you have any doubts, please go back and watch that algorithm video, right? I have explained this. So first element should be less than or equal to the last element, right? I mean the index values, right? And for each iteration, you have to check this condition, okay? Array of middle, okay, I think it's arr. The array of middle, that's the middle element, okay, as you can see the middle element here, okay? So array of the middle position, okay, middle will store the index value again, so array of that index, okay, that element, whether the array of middle, that middle element, array of middle element is less than the search, which means the element which I wish to search. That is the algorithm, right? You have to compare the element with your middle element. Compare the element that you wish to search with the middle element. If that is less, then you have to omit that one part of the array. I hope you remember the algorithm, right? So I say my 30 is the middle element. Okay, I am searching for 35, and if 30 is lesser than the middle element, then I can just omit this part of the array. There is no need for me to search 10 and 20, because the middle element is less than the element 35 which I am searching for, right? So I'll be just searching this right part of the array, you know that, right? So I have to input this condition, and if this is true, then I have to make, if this is true, then I have to make the middle element as the first element, guys. First equals to middle plus 1, right? Why? Because there is no need for me to search left part if my if 35 I am searching is greater than the middle element, that is 30. So there is no need for me to search this part. So make 30 as your first element, that is make middle element as your first element. That's it. Very simple, right? Easy peasy. Okay, I mean this concept is very simple. The element you're searching for is less than the middle element, then make the middle element as the first element and search only that part, right? Super. And you have to use else if ladder. So I'm including one more condition, else if this is not true, then check one more condition, which means the array middle element is equal to the element that you are searching for. I mean, the element is found. Okay, the middle element is the element you are searching for. The element is found. If that is the case, then you have to print that the element is found at position percentage %d, and the position you have to say, so that is middle plus 1. If you are following me from the linear search code itself, then you should be definitely able to understand why I am writing middle plus 1, right? If you have any doubts, please go back and watch that video in linear search C programming. In that video I explain why I am putting index plus 1. Middle is just an index, right? So index plus 1, why I am putting that. So, and this is the end case, right? This means that I have element is found, so I am printing that and I am breaking the loop here, right? Super. And if, yeah, so till the loop will stop, if the element is not found, then you have to search one part of the array. If the element is found, then just print and break it, right? And after coming out of the loop, if the first element becomes greater than, if the index of the first element becomes greater than that of the last element, then printf the element is not found, because you have made all the separations, you have made all the binary separations, and you can't find your element, you can't fulfill this condition, then your first element will definitely become greater than your last index, right? If that is the case, the element is not found. That's it, and you end that loop here. This should be given after the end of the loop. I mean, this should be given outside the loop, right? This should be given outside the loop. That's it. I hope this code will work now. I think I have to give one more condition, right? So here you can see I have to give one more else part. Here you can see that the middle element is less than search. That's okay. What if my middle element is greater than search? Okay, the middle element is greater than the element which I am searching for. Okay, let's say the middle element is 30 here, the element which I am searching for is 20, which means that I have to omit the right part of the array. Okay, I have to omit 40 and 50. If I have one more element here, 50, I have to omit the right part of my array. Middle element is 30, but element I am searching for is 20, which is obviously lesser than the middle element. If that is the case, then I have to omit this part. 40 and 50 should be omitted, which means that 30 should be the last element, right? 30 should be the last element. So in that case, if I wish to search an element which is lesser than the middle element, then I have to make the middle element as the last element, right? So here I just have to make the middle element as the last element. That's it. Middle last equals to middle minus 1. Always have this middle plus 1 and middle minus 1 here. Okay, that's just for normalization sake, right? Yeah, I think this will work, and I have to so till I have to iterate this loop, right? So I have to make middle to be first plus last divided by 2. This is the average condition that I have to give in this loop to iterate, right? Otherwise the loop will not iterate, right? Yeah, I think this will work. Yeah, super. Let me run the code. Yeah, I is undeclared, right? So let me declare that somewhere here. And one more error is that array undeclared. So I think I have wrongly used the word array. I have to use ar. Sorry. I think this will work. Yes, size of the array is 6. Let's go for that. 10, 20, 30, 40, 50. Okay, 10, 23, not 4, 50, 6, not 2. Alright. And one more element, 34. Okay, fine. So I wish to search 50. Element is not found. Oh my god. Oh my god. 50 is there, right? Mm-hmm. somewhere here the error is there. It's run the code. Let's check whether it works. So I'm giving the size as 4, and I'm giving the elements 11, 22, 33, okay, 3, 44, searching for 22, and it says the element is found at position number 2, because 22 is found at position number 2, and yes, this code works perfectly, right? To understand this more efficiently, try to code this algorithm, okay, by yourself, so that you will be able to get this if you have any doubts. And if you still have any doubts, you can always go back and watch the algorithm video again. Thanks a lot, guys.